Okay, so I've got another question from the topic of electromagnetism. We're told a negative charge particle is moving horizontally when it enters a uniform magnetic field pointing down. Draw a diagram and describe what happens. Okay, so we're going to draw a uniform magnetic field pointing down. So this is a magnetic field line, this is a magnetic field line, magnetic field line. And we have a negative charge particle moving horizontally. So you have a negative charge particle moving this way. It has initial velocity v, and it has charge which is less than 0 because it's negative. So draw a diagram and describe what happens. Well, the charge particle is going to have a force exerted on it by the magnetic field. And it's going to be the cross product between the velocity vector and the field vector. So if we're thinking what direction is this, we can use our right hand rule. We can say we point our index finger in the direction of the velocity, our middle finger in the direction of the field, and the direction our thumb is facing is the direction of the force. So the force should be into the page or into the screen. However, the charge is negative. So it's not going to be into the page. That would be the case if we had a proton, for example, a positive charge. It would go into the page. The force will be out of the page or out of the screen. It will be towards us. Towards us. So if we drew this, if we rotated this whole diagram by 90 degrees and we have the magnetic field now going into the page like this. This is our little diagram of these are our magnetic field lines turned on the side. They're still of strength B. The particle is still going horizontally this way, V. It still has charge less than 0. But now, because it was coming towards us and we've rotated this by 90 degrees, it's going to go down. So this will be the force due to the magnetic field. So when it says draw a diagram and describe what happens, these are the kinds of diagrams we should have. We can change the orientation of the diagram, assuming you do the vectors correctly. But what's happening? The field is exerting a force on the charged particle, and it is exerting it in a direction which is at right angles to both the velocity vector of the particle and the field. The orientation, so the direction, is set by the right hand rule, but then it is reversed by the value of the charge. So if you're dealing with something positively charged, right hand rule works straight away. Negatively charged, you find right hand rule and then you swap it. So this is the answer in this case.